Okay, we're on lesson 51. It is November 14th, Wednesday, and we know we have at least one person not in class today. That's Julia. So hopefully, Julia, you're watching this. If you're not, um, well, what can I say? Can't make you watch it. I just hope you are because I recorded this just for you. So, so no pressure, but you better watch this thing. All right. Anyway, that's okay. Julia needs to see it a couple of times too, so it's for her also. Not you, not this Julia, the other Julia. The one that's here today. She likes it she likes it so much she wants to watch it over and over again. Excuse me? No you don't? Mr. James, I'm reporting Julia to as being disrespectful. I want you to give her detention and suspend her and make her wash my car. Alright. So let's get started, guys. We're talking about scientific notation for large numbers. And, not so much in this class. I would say outside of maybe a test, never in this class will you be typically working with numbers that are so large that you would have to use, or so small, that you would have to use scientific notation. But just to get you acquainted with that, maybe even in Mrs. Hoey's science class, you might find yourself using scientific notation or certainly learning about it if you haven't already. And at least you'll be a little bit familiar with it. But scientific notation is a way of taking very large or very small numbers and putting them in a manageable form that we can actually use mathematical operations with to arrive at answers to certain problems. And so to give you an idea, scientific notation would be taking a number like this number here, 9, oh, hang on, where'd my pen go? 9, comma, 4, 6, 1, comma, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 0. Now imagine if you were asked to add up that number plus 4 or 5 numbers in a column underneath it as long as that, and you had to keep on adding this over and over and writing it down and going across. It would take a really long time. If you had to multiply it, if you had to multiply that number by 746,321, I mean, imagine how long that paper would be to get an answer to that problem. So there's an easier way to do it, and that's where scientific notation comes into play. And we have to write this into scientific notation. To do that, we're going to use a number that's going to be look like a decimal, and then it's going to be a power of 10. Okay, that's what it's going to involve. And so when we're talking about it being in decimal form, we know that in scientific notation, that decimal is going to be a number that is going to be larger than 1 and less than 10. And that's going to give us our decimal. And then everything is always in the power of 10. So it's going to be some number times the power of the 10 to some power, And in this case, what we would do is we're going to move our decimal. Our decimal right now is all the way over here. Would you agree? Okay, so we have to move that decimal all the way over to the left so it stops at a point where the number is going to be larger than 1 and less than 10. So we're going to move it all the way over, and we're going to stop it right here. Because if I put the decimal here, I have now got a number that is larger than 1 and less than 10. Would you agree? 9.461. This number right here, 9.4, is more than 1, less than 10. So that's what I'm going to do. I'm going to put in here 9.461. I'm not going to account for all the zeros. If I do, then I don't need to do this. But to see what number goes here, I have to count how many places I moved my decimal. I moved it 1, 2, 3 spots. Right, 1, 2, 3, 4, 5, 6 spots, 7, 8, 9 spots, 9 here, 10, 11, 12 places. I moved it 12 places. So in doing this, I would put down 9.461 times 10 to the 12th power. Okay, that's how I write this way here is how I would rewrite this very, very long number. Okay? I got to include all my non-zero numbers, 9.461, but then so it's this number is still larger than 1, less than 10, isn't it? It is, so it qualifies as being set up the right way, times 10 to some power, and this way here I counted my 12. Now, the way I would make sure if I wanted to is go back 12 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I wind up right back where I started, so I know that I counted correctly, and there's my number. London? This is this right here. That's the scientific notation. All of this. The 9.461 times 10 to the 12th is a scientific way of writing this large number right here. Okay, everybody see that? All right, any questions before I clear it? Okay, I'm going to clear it out. There we go. All right, so that takes us to probably our first example, I would imagine, and it does. It says that there are 8.64, so let me write that down, 8.64 times 10 to the 4th times 10 to the 4th seconds in a day. Show how this number is written in scientific notation. Well, I just did it. Because actually when you read the problem, it says, and I'll write it out so you can see it, there are 8.64, that should be times 10, they say to the 4th, yes, times 10 to the 4th seconds in a day. That's what it says. Show how this number is written in scientific notation. Well, I've already showed you how it is written in scientific notation. Why does it keep on doing that? It does that all the time. Look, I did it again. Don't like that. Okay. All right, so how do we write this in scientific notation? We know scientific notation has to have a number that has a decimal that's greater than 1 and less than 10. Okay, and it's going to be multiplied times 10 to some power. All right, that's what we have to have. So how do we fill that in? We have our number 8, point, right? So here goes our 8. There's our point right there. 6, 4 times 10, right here, to the 4th, seconds in a day. Second, we can put seconds per day. That's how we would write it. Does that make sense? We're taking all the information we need is right here. We're just reading it and then putting it in. And this, once again, this is the scientific notation right here. 8.64 times 10 to the 4th. Now, if you really want to know what does that look like when we write it out, then I would write 8.64, and I have to go over 4 places. 1, 2, 3, 4. So 1, 2, 3, 4. So it's going to look like 86400, or 86,400 seconds per day, or seconds in a day. Okay, so if you were to start counting right now, 1, 2, 3, 4, 5, and you did it like time clock every second, it would take you to get to 86,400, and you'd be here 24 hours from today just getting there. If you were to count 1 second, it would take you to 86,400 to be right back here tomorrow, finishing up. Okay? That's how many seconds are in a day. Any questions with that? Does that make sense? Okay. What you have to know is, in scientific notation, the power of 10, let's see, where's it at? This number right here, the power of 10. That's what we're talking about. And this is really the base 10. This here is the power. But the power of 10 indicates where the decimal point is located when the number is written in the standard form. Okay, that's telling you where the decimal point is located when it's written in standard form. So if you consider, let me clear this out. You consider a number like, let's see, 4.62 times 10 to the 6th. Multiplying 4.62 times 10, it gives you the same effect as shifting the decimal point 6 places to the right. So when you multiply it, when you do the math on this, you're actually getting 4, and we're going to put our 6 and our 2 here because it's already in the problem, and then we're going to carry it over 6 places. 1, 2, 3, I need a 0, 4, need a 0, 5, need a 0, 6, need a 0. Okay, so if we were to multiply 4.62 times 10 to the 6th, that's what we would get. Does that make? And basically what we're saying is we would take 4.62 and we're going to multiply it by 3, 4, 5, 6. We're going to multiply it by this number. That's what we're doing. We're because 10 to the 6 is 1 million. So we're multiplying that by a million. That makes sense? Okay. Yeah. Yeah. Okay. We have this problem here. Write 2.46 times 10 to the 6th, and they want us to put it in standard form. Standard form. So what does that mean? What does standard form mean? Who is that, Chelsea? Oh, Catherine, I can't. Okay, honey, what do you got over there? Right, so if I were to put this into standard form, add a scientific notation, you tell me what I have to do. I move the decimal to the right 6 places. Okay, so and so now I'm going to go, there's 1, there's 2, here would be 3, so I need a 0. There's 4, there's 5, there's 6, right? And let's see, I was right here. 1, 2, 3, 4, 5, 6. There you go, I'm correct. You are correct. That is exactly right. So that number becomes 2,460,000. And you know what? I made a mistake in my calculation on the last problem. I told you you're multiplying that number 4.62 times a million because there's 6 zeros. You're not. You have to account for these 2 places. So actually that it would be 2.46. It would be times, and this is not really the way to do this, so it's not important you remember this, but it would actually be with 4 zeros, not 6, because here's two of your 6 digits are right there. So don't even think about doing it that way. That's kind of something else that I probably shouldn't have even shared with you because it could get a little bit confusing. So forget about that. You're not going to have to do that for the test anyway. So just go back to this. Just go back to knowing this. What I'm showing you right here. This is what you want to know. Right here. That turns into this just by counting our exponents. And we know we have to go over 6 places from here, and this is the number we get. That's all you really have to know. Okay? Now, our next problem, example 2, it says to write 2.46, write 2.46 times 10 to the 6th. I just do this one? I just did this one. My bad. Yep, hold on. Let me get rid of that. Hard to see in the dark. Okay. We got this number here, gang. We got 40, comma, 720, comma, or 000. What number is that, by the way? Right. And here's the challenge. Write this in scientific notation. All right, Emma. 40.72? Is that what you said? 40.72? Okay, no. Hold on. Huh? I don't know. Just finish it first. Huh? To the fifth power or sixth? Sixth? Okay. Does this answer scientific notation? Does that fit the rule for scientific notation, London? What needs to happen? 4.072. Man, what's happening with my pen? Times 10 to the seventh power? Well, let's see. Here's what we have to do. Where's our decimal right now? It's right here, right? So let's count over. 1, 2, 3, 4, 5, 6, 7. Yes, indeed. Because remember, it has to be, that decimal has to be a number greater than 1, less than 10. This is 40, right? Doesn't qualify. 4 does. So this is exactly right. London, you're exactly correct. It's 4.072 times 10 to the 7th. That is the answer to that question. Does everybody understand that? Okay, makes sense? Who has a question? What, honey? I can't hear you. Yeah, she did it wrong. This is wrong. Do not do it this way. Remember that this is your brain on drugs commercial or something? Remember to show you an egg frying in a pan? This egg is your brain. This is your brain on drugs, and it throws it into a hot pan. Yeah, it's an old commercial. This is your brain on drugs way to do it. No offense. Nothing against the person who said that. I'm just making a point that this is the wrong way to do it. Although it looks kind of pretty now. It is. Wait a minute. Well, hang on. Now wait a minute. I'm feeling like I need. Yeah, I need No, I don't want grass there. I need. Hold on. No, I know what I need. No. Yes. It's not a rock. It's a little pond. And every pond. Stop that. Why is it doing that? It never did that before. Alright. That's got to go down. All right, we have one problem left. Okay, and this one, I'm going to write it out for you actually. Hard to see. Easy to see. Easier to see. Okay. Here we go. We're going to compare 1.2 times 10 to the fourth. We're going to compare that to 2.1 times 10 to the third. Okay, greater than, equal to, or less than. How would we do that? Who raised your hand? Is that Amanda in the front? Amanda, what's up, girl? Okay, quiet, please. 4 times. So I'm at 1.2. I have to go 4 times, right? There's 1, so it takes me there. There's 2, I have to add a 0. I can add another one. 1, 2, 3. Got to add one more, don't I? 1, 2, 3, 4. So I'm right here. So this changes from, oh, let me make this a little bit smaller. I got to get rid of that. And now we moved it all the way over to here, didn't we? So I can put a comma in here. It's 12,000, right? And we got our comparison sign there. And what are we comparing that to? We're comparing that to what? 2.1. It needs 3 zeros or 2 zeros, right? Because we're going over 3 places. 1, 2, 3. So my decimal ends there. I got to erase that one. So what's my answer? Right? Exactly right. Because 12,000 is greater than 2,100. Make sense? Not that difficult, is it? Okay. All right, guys, we have our practice set homework to do. This class is over today at 12:45. No, 12. Oh, is it 12:45? Okay. Well, it's 12:44. So turn the lights on, please, and we are done. See you, Julia. Hope you feel better. See you tomorrow in class.